Hi everyone, welcome to our video on an application problem involving inflection. So they'll often say those keywords about concavity or inflection points. However, in this problem, they use a different type of vocabulary. They use the points of diminishing return, which is really just finding the inflection point. Okay, so it is still a concavity problem. And it just slight change in the vocabulary. So if they use some special vocabulary, no big deal. We can still decipher it, and we'll still work on these problems the same way. So it's really concavity. So really concavity isn't. So when I think of inflection, I think concavity, which means I need to break this down to get a second derivative set equal to 0, and then continue through our process. All right, so let's read it, though. So it says, Al's car dealership found that the percent of cars sold in a day is given by capital P of X equals that function, where X is the number of salesmen walking around the lot. Find the point of diminishing return. All right, and we'll explain that, too, with our final answer. All right, so really what we need to do first, the domain. So usually our step process was find the domain. We can skip this because based on our answer, we can go back and make sure it makes sense. So just ask yourself at the end if it makes sense. So for instance, if we got a negative value here in this problem, then that wouldn't make sense. So we either messed up or it's like some type of trick question. Okay, so or if we got like the number of workers should be 1,000. Well, that's probably wrong too. So we'll figure it out though as we go through it. Okay, so we're going to skip the domain. The actual domain of a polynomial would be in negative infinity to positive infinity. And again, this really doesn't make sense anyway because of an application. So we wouldn't have negative as an answer. Okay, so that's again, just moving on. So step 2 though is let's get our derivative. So we need to get our second derivative. So our P of X, so instead of f of X, it's P of X. Okay, no big deal. Let's go ahead and write out. They use some weird decimals. Okay, so we'll need probably a calculator to help us. All right, but let's do our derivative. So we need the second derivative. So we need the first derivative first, though. So we would have negative 0.15x squared using the power rule, and then plus now 0.912. I'm going to use my calculator. This one that's just on the computer. 0.912 times 2, 1.824. Okay, so let me just kind of keep that over there. Okay, so 1.824, and then x, so the 2 multiplied that, and then this one's nice, 0.45. Okay, so that's the first derivative. This is good for increasing and decreasing problems, but let's move on. So we want the second derivative. So the second derivative, the 2 would times that, and we'd get negative 0.3x, and that's it. And so minus 1 from the x, there we go. And then the power rule for this portion is pretty nice. It's just 1.824. And then the derivative of the constant is 0. Okay, so this is the second derivative. And then now I want to find my critical numbers, which is to set the second derivative, equal to 0. And then we'll solve. Okay, so I can add that over to give me 0.3x equals 1.824. And then we could do that division. I'm going to use my calculator. There it is, 1.824 divided by 0.3 gives us 6.08. Okay, so we got 6.08. All right, so that is our critical number. And this should be the answer, and we could probably skip a few steps to be done with it. But just to verify that I will have an inflection point, okay, so at 6.08. So our domain for this problem, 0 workers would be the minimum. We couldn't have anything less, so I am just going to put 0 down. But I'm going to kind of just note that to the left, I don't really care. So these are our x values, and then I want my second derivative, and then I want my concavity getting known here. Whoop. Let's go ahead and draw our 2 second derivative helpers. All right, and then all I want to do, so I just want to verify that this is an inflection point. So I just want to make sure I see that there's going to be a change in concavity. So if I plug the second derivative, a value of anything bigger than 6 in, so let's do 10. into our clouded function. So I'm going to start now. So if I plug that in, this would be negative 3 plus 1.824. Well, that is negative. So this is a negative value. And then if I plug in anything between 0 and 6.08, let's do 1. If I plug that in, I would have negative 0.3 plus 1.824. And then that is going to stay positive. So yes, there is a change in concavity. This is concave up because of the sign here. This matches our F's concavity, and then this is concave down. Looks like a frown. There we go. Okay, so we definitely have an inflection point. So it is verified. The inflection point is there. Okay, and so find the points of diminishing return, which is the inflection point. Now, with this, the 6.08, so you can't have 6.08 workers. We would probably just use 6 workers to get the actual, so this was step 5, and then our other step 5 in our process was to list the concavity, but we don't need that, so we're just going to go straight to the inflection point. And the inflection point would be when you plug 6.08 into the function. So that parenthesis was too soon. We would get this y coordinate. Okay, so let's go ahead and get this y coordinate, which is plugging 6.08 back into our original function. Okay, so which was the one that was in the problem right there. So I'm just plugging 6.08 into that x. Well, at this point, I am going to go ahead and graph it to see it a little bit better. So let me get my... There it is. And let me go ahead and plug that in. So negative 0.05x cubed. And then plus 0.912x squared. And then minus 0.45x. Okay, so it looks like this. And then it's tough to tell, but it does look like it is concave up. And then it changes to be concave down. Let's get that 6.08. Okay, so I'm going to use my table just to type it in right here. So 6.08 is that point, the 19.74. Okay, so that is our y coordinate, 19.74. Okay, so that's what happens when we plug 6.08 into our graph. We got our y coordinate, and that does look like where it changes concavity, so it is concave up until there, and then it looks like, yeah, it is definitely concave down afterwards. Okay, so that's the point of the diminishing return. Okay, so what that means for this problem, so this is the actual point. So it's kind of abstract. There should be x equals 6 workers, because again, you can't have a decimal, and so I'm just rounding to the nearest to find the points of diminishing return. So what that means is if they get more workers afterwards, so more workers, more than 6 workers, 6 workers, their profit is not increasing as well as it should, or their profit does not increase as well. And so what could be happening, like if it's a real life situation, maybe 6 workers is the maximum that's needed to get the cars sold, to get them moving. Whereas 7 workers, maybe that 7th worker doesn't do as much. So now the manager's paying someone else that can just sit around and not help other people. Maybe there's only 6 workers that are needed because at any given time there's 6 customers max. And so you don't need extra workers if there's not as many customers. Okay, so that's what it's kind of breaking down as. The 19.74, so that would represent a percent of the cars. So they're saying 20%. So this is made up, obviously. So 20% of the cars are being sold in a day. So that probably doesn't make sense either, but that's okay. So for this scenario, we're going to assume it does. So that does represent a percent. 19.74% of cars are sold. Whereas if you start to increase workers, maybe this percent doesn't really go up too much, and instead you're wasting time with paying extra workers. All right, so anyway, so that is it. So I'm going to say, let's box this. That's probably how they would want the final answer. But we've broken it down in different phrasing to match anything that they might want. Okay, so that's it. So that's if you have the points of diminishing return. Again, other word problems will just probably say concavity or talk about inflections. And so from there, then we could find out whatever they want. Or if they give you some other vocabulary, they probably have to point out that, hey, that means inflection point. Okay, anyway, so that's it. If you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.